Can computers think? And the second question is, could computers ever be able to think? Yes, hello everyone and welcome. Yeah, my name is Jamal Victor Yope. I'm a student at Makerere doing software engineering. So we're going to dive into this main question immediately because yeah, we value our time. So our question, and there are two questions which are very vital and important questions. They aren't new, but yeah, we shall discuss about it. So the main question is, can computers think? And the following question is, will a computer ever be able to think? So, we're looking at this in the perspective, of the pre-purchase inspection. Pre-purchase inspection. So, pre-purchase inspection is the assessment of the mechanic, electrical, and different systems of a vehicle. Because most vehicles, especially the imported ones, or used vehicles, they come when they have their own issues with them. Now, because you may buy a vehicle when it has issues with the braking system, with the hydraulic system, and before you buy, you have to know what condition your vehicle is, or your automobile, maybe a motorcycle. So the pre-purchase inspection, it deals with this, and in the pre-purchase inspection process, we have computers that are involved and tools that are involved in this process. So how are computers able to think in the pre-purchase inspection perspective? Yeah, so we know that technology has advanced and we have modern diagnostic tools that help improve the process of pre-purchase inspection. So these are the tools that input data and they process it and then they finally output data. But is that called thinking, or is it syntactical? How can we explain this? Yeah, so let's break this down by understanding what PPI is, or pre-purchase inspection is. Yeah, so as I explained in the beginning, pre-purchase inspection is the in-depth check or assessment of a vehicle automobile in order to see or determine its value to the customers. So this, as I said, it's based mostly on second-hand cars or cars that are being bought from someone, so that you can determine the value or improve on the vehicle based on its functionalities and its problems, the issues that it has. Yeah, so it's conducted by a professional mechanic. That's where the semantic part comes from. This is someone who has experience and knows how to use the computer tools that he has. It's conducted by a professional mechanic and covers exterior, interior, and diagnostic mechanical systems. So some of the tools the mechanics use, we have the OBD scanners, and we have the multimeters that measures the electrical uh, parts of the vehicle or motorcycle. Then we have the pressure gauges that also measure the pressures that are in the vehicle and that they have. Purpose of this process of the pre-purchase inspection is to identify the problem or the issue with the vehicle or with the motorcycle, whatsoever it may be, so that it can be implemented, and also the customer knows what value the car has, other than buying something at a given price and yet it has a lot of issues with it, a lot of problems, where you'll have to invest in repairing it, yet you paid more for something that costs. Yeah, however, analyzing the computers, we realize that even though they help in the pre-purchase inspection, they may be able to get the data, the diagnostic data, and they process it, but it doesn't mean that they have semantic understanding. That's according to Saley's Chinese room principle. Saley's Chinese room statement, because the fact that the computers are able to gets this data and apply it or produce an output, it doesn't mean that they gain the understanding of what is behind it, of the whole context. Looking at our next slide, we have to see where human thinking applies in the pre-purchase inspection. So we know mechanics are experienced. Obviously, you won't be able to allow an inexperienced person to check on your system because he will fail to find the faults. So a mechanic is a person that has experience, intuition, and judgment. So when he detects a problem, he knows what's the cause and what is the possible solution of the judgment. So, for example, recognizing unusual engine sounds. When he's trying to start your vehicle and it's sounding differently, he can know what is the problem. So, another example, you can see judging wear on brakes or suspension. Ex- Explaining, we also see that is able to explain safety, the cause, and the risk to the buyer based on the value of the vehicle and the issues that the vehicle has. So, all that, it involves understanding. So, that is semantic understanding, whereby he's not just following rules, but he knows what it means when the brakes have a given issue. He knows what it means when the car produces a given sound. That is semantic understanding. So after looking at what the human plays or the mechanic plays, we should also look at which role computers play. Because we are diving into the question, can computers think? That is syntax versus semantic. Yeah, so computer roles in PPI, that is, as I said, pre-purchase inspection, we see they have different roles, but just breaking them down, computers are able to identify problems without dismantling parts. So as long as you are able to access the point that has an issue, you don't need to dismantle the whole car in order to know the pressure that it has. You have to access a given part so that you can be able to get the pressure. Yeah, another thing is uh, computers provide measurable and objective data. They provide data that you can rely on because in most cases they are accurate when providing that data. Another one is computers, they increase inspection efficiency, even like they limit time, something that you'll need to take a long time in when you're trying to check on the system or their parts. Using a given tool can simplify that work that you're doing. And the final point is they reduce human error. As we know, most computers, like we as humans, we do a lot of errors. So some of these tools used in the pre-purchase inspection, we have the OBD that I spoke of earlier, which is onboard diagnostic systems. Yeah, and these systems, they allow quick retrieval and processing of codes. So whenever they retrieve and process codes based on the issue that has been gotten with the car. So whenever that code is brought, the code represents a given issue, a given problem that is with the car. So for example, when it's checking on the some of these tools, when they're checking on the engine, whenever the engine misfires or there is a technical issue, it's able to bring an error that the mechanic knows the solution to or knows how to deal with. Yeah, so let's move to the next slide. uh, in summary, computers support inspection, as we have talked of OBD2 scanners. We have sensors and other diagnostic tools. So diagnostic and maintenance, where these computers are applied, they they facilitate remote diagnostic and provide real-time data on vehicle health, enabling predictive maintenance and prevent breakdowns and reduce downtime. Because when they provide this data, the user or the person who's going to buy the vehicle knows how their vehicle is going to function and how they should maintain their vehicle in case it gets an issue or when the in case they want it to take a longer time. So we see that computers are really involved in pre-purchase inspection, but they have their advantages and limitations as well. We have seen some of their advantages, like strength that we have spoken of, speed, accuracy, and the objective measurement are part of that. Then we have limitations, that they don't have understanding of the context. They don't have, they are there to get that information and give it to you. That's what they are programmed to do. But they don't know the context. They don't know whether the car is being repaired. They don't know whether someone is just doing a study. They don't know that they are trying to evaluate how much they can value the vehicle for. So they don't have uh, the context of it. Yeah, so we are continuing to break this down so that we can come to our final conclusion of the question, so that we can get our answer. So we looked at syntax and semantics before, and we had summarized that syntax is refers to the order or the rules that you follow in order to get something. Then semantic is the meaning, the logical understanding of that statement or sentence that you have achieved. So for example, we see some OBDI tools, they're able to provide codes. So there is a common code that is P0301. Often, or it represents cylinder misfire. So this is what the computer provides, but it doesn't understand what is the meaning of this and what would be the proper solution to this. So it reads the error P030, which means cylinder misfire. What to do next, it doesn't know. So that's where the semantic comes in, the mechanic comes in, is able to know the understanding that when the cylinder misfires, the vehicle obviously need a small repair, or I will have to do this and that. That's where the semantic comes in. Then it's able to process data, provide the certain information about the vehicle based on what you have been wanting, whether it's the pressure, whether it's how the engine has been working. It's able to process that data, but it doesn't know what to do with it. So the human or the mechanic is able to interpret and know the context behind it, is able to know that this kind of car is this years old, and I have to deal with it in such a way based on the data that I've gotten. So proceeding to our final question, we are summarizing now. Proceeding, that can computers think? The pre-purchase inspection perspective, computers, they simulate aspects of thinking by applying algorithms to detect, classify, and report faults. We have talked about this, that they detect those issues that the vehicle has, depending on which part and which tool that you're using. But they lack semantic comprehension. Uh, an example that we can understand is computers, they follow programmed rules to simulate reasoning. This reasoning is in form of the output they give. So when they have detected the error, they produce an output that it's this error. So that isn't thinking, but it's kind of resembling thinking. It's simulating what thinking would be like. So computers as well, they can't explain repair agents or the car value, the car's overall value. So remember, our major aim for the pre-purchase inspection is to know what is the value of this car before it's sold to the customer, or before the customer buys it. So the computer is just applied in a given point where we need it, but it's not able to know the overall value of the car based on the issue it has detected or the fault that it has found. It is the mechanic who knows the conclusion of it. Yeah, so limitations of computers, we see absence of judgment. It's not able to judge, how can I deal with this? Yes, you have produced the error, it means this. What next? What are you going to do after getting that error? It's not able to judge. Lack of contextual awareness, we have spoken about that, whereby it's not able to know how long this car has taken or which other parts have issues that are leading to these issues. That one involves the need of a mechanic who has the semantic understanding. Computers are limited to rules, hence hardly adapt. So we know the computers, they are programmed, these systems are programmed to do certain things. So in case another thing is not adjusted, the computer may be limited to get that thing or to find that error. But as a human who has semantic understanding, you will know that there is something missing and it needs adjustment. So, in conclusion, the question that is asked, that can computers think? The conclusion is computers are necessary for pre-purchase inspection, but they do not really think. And we have explained the most important reasons above in the slides before. Following next is our next question, that could computers ever think? That yes, right now they only have the syntactic ability, but will they get the semantic ability? Yeah, so this question extends the debate into the figure of computers and automotive diagnostics. Could machines in PPI evolve into semantic reasoners? Here, the robot argument applies directly. That is Searle's argument. Computers, diagnostic computers, are powerful at processing inputs, that is syntax, that they're able to get that input and process it to give you an output, but are not capable of semantic reasoning about vehicle health, repair agents, or consumer decision making. So they give you the output that you want, but they're not able to reason of how the vehicle has been functioning before, its health, what is needed to be repaired, and how urgent is it to be repaired, and how the customer will decide whether they want to buy the vehicle or not. They're just specific to follow the syntax, the rules that they have to follow in order to detect the problem that is with the vehicle. So we know that thinking, according to me, thinking requires consciousness. It's not just you needing to follow rules in order to produce an output. It needs consciousness to think, to understand something. So, while computers approximate thinking in PPI by offering advanced recommendations and contextual predictions, bringing the syntactic semantic gap remains unresolved. Covering this gap is still an issue because there is a huge difference between syntactic and semantic reasoning or understanding. Syntactic, you just follow rules to produce something. Semantic, you understand and know what is behind all of it. You know the logical meaning of it. So true thinking requires consciousness and not just computation. You don't just need to follow rules. uh, you know that you are thinking. It needs reasoning to know why are you doing this, what will be the effect of doing this. Yeah, so in conclusion, computers do not think, they simulate. They don't think, they simulate uh, thinking, but they lack semantics. They want to they are close to thinking, but that's not thinking because they just follow rules, but they lack semantics. They are not able to understand the context of what they are producing. Then computers could possibly advance in future, uh, but I don't think they'll reach the point of thinking. That's my perspective, but I don't think so. Yeah, so that's the summary of it. The difference between syntax and syntactic, how it's applied in pre-purchase inspection, Yeah, my name is Jamal Victor. As I've told you before, Yope is my third name. And thank you very much. See you next time.